Axonic has a feature to measure pole lean, bending, embedment, and height. And in this video, we're going to have a look at how to do those things with an Axonic. So what we've got here on screen is a multi-measurement that's been taken of a pole. You can see that a point has already been put at the ground line position for this pole. And if we look in the menu here, you can see that a distance to the pole has been entered. The other thing we can add in here is the support type. Now this pole is a busk 9.5 meter, and we can add that in there. And then to do all these, the lean, bending, embedment, and so on, what we need to do is then we go to the process tab. So in the process tab, we pick this pole button on the bottom left. And then what we can do is, if there are multiple poles, then you'll use the cycle button here to go to the pole that you want to measure. And then what you do is you push the middle button here to identify the pole top position. So if we select that, we zoom into the pole top, and then position our crosshair there, and you can see it's already come up with the height of the pole. And if we look in the menu here, well, this panel that slides up, you can see that it's recorded the apparent lean of the pole. You've got your the length, the vertical length, and it's estimated the embedment. Now the button here, this middle one, that allows us to enter a midpoint on the pole. And what this allows us to do is to measure the bending of the pole. So now we can see that the apparent lean is actually made up of a ground line rotation of 0.6 degrees and a bending lean of 1 degree. So this pole has a lean that's comprised of both the pole bending and some ground line rotation. So this allows us to discern between the two. Just going and looking at these, we've got this estimated embedment of 1.78 meters, and we can see below that it's actually said, because we know the pole type, we put in there the busk 9.5 meter, there's an embedment variance of 180 mil, which means it's embedded 180 mil deeper than the nominal embedment for that pole. And it's written a different way here as well. It's got the embedment nominal fraction, so it's at 111% of the nominal embedment. The other things that we've got here is a deflection number, so it's deflecting by 225 millimeters, and then it also splits that out into the amount of deflection based on ground line, because of the ground line rotation, or due to the bending deflection. So that is the feature for measuring the pole height, lean, embedment, and bending.